Hello everyone, this is the second part of Thursday's homework. It says use substitution with trig sub. If you look at the book, it gives you a recommendation for a substitution, and the whole point of this is to get you in the habit of remembering and recalling some of these old trigonometric substitutions here. So if you look in the book, they even give you a substitution to use. They say use sine squared of 2x equals 1 minus the cosine squared of 2x here. And hopefully you remember this identity. This is just sine squared of blah blah equals 1 minus cosine squared of blah blah, right? Now when we did it, we just put an x, but that would be the same thing as if you put a 2x here, that's all they're asking you to do. And you might be asking, okay, so how does that connect with this integral here? Well, we have to use this substitution somehow, and theoretically we're going to rewrite the problem in a way that we can use substitution appropriately here. All right, so what I'm first going to do is I'm going to demonstrate why I just can't let this, why can't I just use a u sub immediately. So let's go ahead and do that really quick. So let's just say, I'm going to rewrite this here, which we know this is sine of 2x cubed here, dx. And if you notice, this here, this has two inside functions. It has sine of 2x, and then this whole thing is cubed, and then you have the 2x here, right? So you could let u be 2x, you could let u be the sine of 2x, right? So I'm just going to try a bunch of different things here. I'm going to do it, what I'm trying to say is I'm going to do it wrong. So first I'm going to let u equal here, hey kitty, I'm going to let u equal 2x. Let's just say I let u be that one. Okay, so let's check what du is. Du is what? That would be just 2 dx. Now the problem with that then, if I rewrote the problem, is if I get the integral of sine of u cubed, right? And I could adjust this here, and I could put a 2 with the d here, with the dx, and a 1/2 here to correct it. And then I could substitute in, so I'd get 1/2 times the integral of sine of u cubed du. But if you notice here, you can't really anti-differentiate this. Why? Well, think about it. What derivative gives you sine of something cubed? And you can't do that. So it's not going to work. So if you're lost on this, just try and think of this in your mind. Like, what derivative is the sine of x cubed? What derivative gives you this? Can you think of it off the top of your head? It's not sine, it's not cosine, it's some other function, so this is non-elementary. So what this means is we've kind of failed because we haven't really made the problem into something that we can solve readily, so this was the wrong step to choose, okay? So now what I'm going to do is I'm going to do it wrong again. I'm going to let u equal this whole inside function here, right? Why can I do this? Sure you can, absolutely. But now we're going to say du. Remember, the goal is when you take the derivative, hopefully you're going to see it here, and it's going to be easy to recognize because we're doing the chain rule in reverse, right? So we're trying to look for the derivative or times the derivative of the inside function. So if this is my inside function, the derivative of it, the derivative of sine of blah blah is cosine of blah blah times the derivative of blah blah. So it's going to be cosine of what? 2x times the derivative of 2x, which is 2, and then times dx here. Here's my little dx. I'll just rewrite du so we can see it. We get 2 cosine of 2x times dx. But the problem now, as you can see, we have, you can plug in what I have here. So let me rewrite this. So I get the integral of, so sine of 2x was u cubed, right? And then dx. The problem now is I have this dx here, and I have a dx here. But what I don't have is I don't have a 2 cosine of 2x here. You see that? See how I'm missing this piece here? Now I can correct with a constant. You cannot correct with a function. See, if I had a cosine of 2x, I'd be home free. But since I don't have that here, I can't integrate this because the only way to integrate this is if I have the same variables here. So I need them all to be used. And the only way to get that is to get du. And the only way to get that is to have the cosine of 2x. So this substitution also fails. So I'm going to do the recommendation they have in the book here. I'm going to split this up. So you know that sine cubed, right? Because that's just sine cubed. So that's sine squared times sine. So I'm going to write that here. So that is sine of 2x squared times sine of 2x dx here. So just double check to make sure that I've done this properly here. So if we note here, cubed is just the squared times one of them, right? That's all I did here. And now I'm going to use one of the substitutions that they recommend, which is to use 1 minus cosine squared of 2x. I'm going to plug this component here in here. And you might be saying, well, why am I doing this? Well, hopefully it will bear fruit. Because remember, the goal is to see one of the derivatives there, right? So cosine squared of 2x times sine of 2x. And we'll go ahead and put a little dx here, right? All right. So theoretically speaking here, we should have some type of better problem, but it looks just more complicated, right? So now we're going to let u be one of these guys here. Okay, so what do you want to let u become? Well, why don't we let u be, if you're not sure, well, let's rewrite it, because it kind of looks confusing, right? Let's rewrite this. So what if I wrote 1 minus cosine of 2x squared, right? And then this is times sine of 2x here dx. Now, it doesn't always work, but a lot of times use the inside function. As you can see here, the inside function, there's a few functions here, but I have sine of 2x, but I also have cosine of 2x squared, and that's kind of more on the inside than sine, so I'm going to try that one. I'm going to let u equal the cosine of 2x, okay? And then we're going to go ahead and say du, the derivative of cosine of blah blah, is negative sine of blah blah, times the derivative of the blah blah, okay? I'm going to clean this up. Oh, sorry, I forgot my dx here, right? And as you can see, that u substitution did bear fruit. Why? Because I have sine of 2x and a dx. Sine of 2x and a dx here. See? It's only off by a constant of negative 2. Negative 2. If you want, I can rewrite this here. We have negative 2 sine of 2x times dx. So I have that here, right here. Look, all I need is a negative 2, so I'm going to multiply this by negative 2. And if I multiply by negative 2, I need to correct it with a constant multiplication by the reciprocal of whatever I multiplied by. So I'm going to multiply by negative 1/2 here. And now I'm going to rewrite my problem way down here. So I have what? Negative 1/2 times the indefinite integral. I'm going to substitute in 1 minus cosine of 2x. Cosine of 2x is u, so 1 minus u squared. And this whole thing is now what? Du, right? So we're going to put du, and now we have something we can very easily anti-differentiate. We're going to do that now. So we get negative 1/2 times what? Because I'm putting brackets because it's a binomial, the integral of 1 with respect to u is u minus the integral of u squared. If we add 1, it is u cubed times the reciprocal is 1/3 u cubed. Okay. Oh, sorry, plus c. And now we go ahead. I'm going to distribute this just because we should get in the habit of such. So we get negative u over 2 minus, plus u cubed over 6 plus c. And that should be the final answer. Let's check to see what they have. Oops, and I've fallen into my own trap. I got a little excited here. Did you know what I did wrong? Hopefully you know, as I failed to resubstitute what u was. And what was u? U was what? Cosine of 2x, so this is wrong. So what I get then is I'm going to substitute back in. So I get negative cosine of 2x over 2 plus cosine of 2x, the quantity cubed, over 6 plus c. And this is my final answer, not the original one here. Now this one makes me happy because I got it right.